Good morning, friends. I feel immense pleasure to be here again for my course, Aircraft Systems. As you know that I have completed all the 5 modules. Now I am in another section that is called a case study or some more detail about some systems. So in today's topic, I am going to discuss about aircraft hydraulic systems. We have seen in my previous lecture that aircraft has got different controls. Aircraft also have landing gears, doors and all. These all items or equipments or components are operated by the help of the hydraulic system or electrical systems. But the hydraulic systems are more popular systems in which the hydraulic fluid is used. This hydraulic fluid is pressurized by the pumps. These pumps are operated by engine or some electrical motors. They are pressurizing and then this goes to some different valves. These valves are like non-return valve, shut-off valve, selector valve, pressure relief valve, pressure regulator valve and so on. It goes and after that there is a filter also and reservoir, accumulator also. So these are some components by which we are making the hydraulic system, and these hydraulic systems are used to operate the actuators. Actuator is a device which moves fore and aft or in the rotary. 2 types of actuators are there. So these things are used for this purpose. As you know, my name is Dr. Yagya Dutta Dwivedhi. I am professor in Institute of Aeronautical Engineering, Hyderabad, India. And today I am going to discuss the aircraft hydraulic system, which covers the following topics. So topics and CO mapping in this. So topic number 1 is hydraulic systems and the components. The course outcome is CO3. Working principles of hydraulic pump. This is also part of CO3. Fluid conditioning, also CO3. Warning status, CO3. Emergency power sources, CO3. Yellow and green system of the hydraulic, that is also part of the CO3. Here I am going to talk about some introduction about hydraulic piping. So when the system architecture is defined for all aircraft systems using hydraulic power, then it is possible to design the pipe layout in the aircraft. So first thing, we have to know the system architecture, how the hydraulic system has to be laid out and where this equipment is to be located. According, if you know these all things, then how much power this hydraulic system is required, how much pressure the pump is generating. By knowing this all information, we can design the size and the layout of the pipe as per the flow condition and other requirement of the aircraft. This layout will take into account the need to separate pipes to avoid common mode failure due to accidental or battle damage. So this layout will take into account the need to separate pipes. So we should also take care of that if any accident happen or some damage happen, especially for the military aircraft, some bullet or some bombs or some missile is hit. What is the next way to make sure that your hydraulic system is not failed or the hydraulic fluid is not leaked? So this layout will take into account the need to separate pipes to avoid common mode failure due to accidental or battle damage. It is possible to measure the length of pipe and to calculate the flow rate in each section and branch of the pipe. So we should also able to calculate the how much flow is required and for each section and branch of the pipe. So that is also very much required to understand. Allowable pressure drop of 25% has been selected throughout the system. So this 25% of drop is permissible. This may now be further divided between pressure pipes, return pipes and the components. So we can have the pressure area, then the return area, and also the different components your system will be moving. Everywhere we need the pipe. So how the pipes are laid and how these pipes are designed. Once pipe length, flow rate and the permissible pressure drop are known, pipe diameter can be calculated using the normal expression governing friction in pipes. So if we know this pipe length, how much is required, the flow rate, how much is required, and how much pressure drop is permissible. If we know these three things, then by using the equations of normal frictional flow in pipe, we can calculate the diameter and other material, and we can design and we can fabricate as per the requirement. Next is the hydraulic pump. So in this previous slide, we have discussed about how the piping is decided and how these things are designed and what are the criteria required. Like if you know the pipe length, if you know the flow rate, and if you know the pressure drop, we can find out the size and the diameter of the pipe. Next, very important component is hydraulic pump. So this hydraulic pump will give the pressure, and how much pressure is required. As you have the high pressure, that much efficiency of the system can work. So a system will contain one or more hydraulic pumps due to need of redundancy. You know that redundancy is the ability to sustain in case of failure. So we need the single redundancy, double redundancy, triple and quad redundancy is required. So as per the redundancy, how many systems or hydraulic pumps are required in the hydraulic system? Pump speed is directly related to the engine speed. The speed of the pump, because the pump is connected with the gearbox of the engine, if the engine speed is high, the gears will rotate at high speed and accordingly the pump will also rotate. So it is directly proportional to the speed of the engine and must therefore be capable of working over a wide speed range. So our pump should be able to function at a more range of speed. Slow speed, medium speed and high speed, all type of speed, the hydraulic system should be able to function. The degree of gearing between the pump and the engine varies between engine types. So what type of gears are required? Which design is required? This depends upon the engine types. We use the piston engine, they are slow running. If we use the gas turbine engine, they are very fast running. So which type of engine we are using? Accordingly, the gearbox of the hydraulic system has to be designed. A typical maximum continuous speed for a modern military aircraft is 6,000 RPM. So a typical maximum continuous speed for a modern military aircraft is 6,000 RPM. This is largely influenced by the pump size. The smallest pump running fastest. So as much you have the smaller pump, the size is small, the pump will run fast. The universally used pump type is known as variable delivery constant pressure. Mostly we use variable delivery and the constant pressure is constant. Pressure we make the constant and delivery flow of this thing is varied as per the requirement. Demand on the pump tends to be continuous throughout a flight but frequently varying in magnitude. So demand on the pump is dependent upon the flight condition. If you are in high speed, if you are low speed, if you are doing maneuvering and all, for different types of flight, you need a different demand conditions, but frequently varying in magnitude. So this pumps will vary its magnitude now and then as per the speed of the aircraft. This pump wastages are less and meet all sort of the demand. So these hydraulic pump, their wastage should be minimum and in all type of flight, they should be able to operate. These pumps can maintain pressure within 5% of the normal pressure. So within 5% of the normal pressure, if suppose it is 100, so plus minus 5% Pascal it should be able to operate. So only 5% of the variation of pressure is permitted. Optimize the overall efficiency of the system. The hydraulic system, the efficiency of the system has to be optimized. Now, next is the characteristic curve for a constant pressure pump. So normally, just now I have told that normally we make the pump in such a way that the pressure of the system is constant, but its demand and its delivery can be varied. So variable delivery and constant pressure systems normally we use. So here I have drawn a characteristic curve for a nominal constant pressure pump is shown in the figure as it is given here. The pumps are designed to sense outlet pressure and feedback this signal to a plate carrying the reciprocating piston. The plate is free to move at an angle to the longitudinal axis of the rotation of the rotating drive shaft. There are normally 9 pistons arranged diametrically around the plate. The position of the plate therefore varies the amount of reciprocating movement of the each piston. So this is about the pump, and here I am showing you a flow here and here the pressure. So you can see as the pressure is increasing, the flow rate is slightly decreasing up to here. But as the pressure is increased more than this, this sharp drop in flow is there. So our range of working is from here to here. This is the area where our system should work. Up to 5% pump internal leakage is permitted. Means if here the flow is 100 meter cube per minute, so here only 95 is acceptable, not more than that. So in aircraft, this is the criteria which we have to follow, and this is called the characteristic curve for a constant pressure pump. Now, working principle of hydraulic pump. Just now in the previous also, it is already mentioned here. The pumps are designed to sense outlet pressure and feedback this signal to a plate carrying the reciprocating piston. The plate is free to move at an angle to the longitudinal axis of the rotating drive shaft. There are normally 9 pistons arranged diametrically around the plate. The position of the plate therefore varies the amount of reciprocating movement of each piston. Here this you can see, here is a plate, this is the plate, 1, 2, 3 it is shown. So in the same series, 9 pistons are there. They are the spring loaded here. This you can see, fluid outlet, feedback is here from this side. This will sense here, fluid, it is a outlet and this is a return line, cylinder block, reciprocating piston, and here is the drive shaft. It is rotating like this. This plate will rotate like this. So here, when the plate is at 90 degree to the linear axis, there is no linear displacement of the piston. Up to its maximum limit, the plate will move to displace the volume needed to maintain nominal system pressure. When flow demands beyond maximum displacements are made, the system pressure drop rapidly to zero. For short period, pressure can be maintained by means of an accumulator. So just you can see here that if you see here, this one is low pressure and this is the high pressure here, because it is pressing more here. Here the pressure is less. So from here to here it will go like this. And in this way we have the 9 cylinders. So one will be the highest pressure and another will be almost zero pressure. And this will be rotating one by one. And in this way, our hydraulic systems are working, and the hydraulic pumps, the reciprocating systems are working in this way. Here I am showing some drawings of hydraulic pumps. So they are from the Vickers, and here they are from the reference 1. These are the, so these pictures are taken, the hydraulic pumps are looking like this. They are very simple, very small, just maybe 1 kg or 2 kg of weight, but they are made very complicated. Here if you can see, there is a inlet and outlet like this. Here if you see, the gearbox is connected, the shaft is entering and it is rotating, and here is the hydraulic accumulator, and these accumulators are the devices where fluid is stored with high pressure due to the pressure of the air or the nitrogen. So this I am going to discuss in, I think, next slide. This special detail of these figures are available. Now, fluid conditioning. So the fluid conditioning means we should try to make the fluid or the hydraulic fluid very clean. It should not be leaked. It should not be contaminated. Other fluids should not be mixed with this hydraulic fluid. So we should have different types of filters. Here we have the filter, return line, filter, case drain, filter, low pressure. So different things are here. Here some typical filters unit taken from reference 1. So now hydraulic fluid need cooling and the cleaning. So first thing, the conditioning, we need a cooling and the cleaning. Your fluid should not be hot, because it is working with the gearbox, a lot of pressure is there. The tendency of the hydraulic fluid is to become hot. But if it become hot, it will reduce its quality. The hydraulic properties of the fluid will be reduced. Fluid should not be dirty. No sediments, no another particles or some dust particles or some other material should not be mixed with the fluid. So we need, for this, we need a filter. Bleeding of air needed from the hydraulic system. So if any time the air is trapped inside the line, this will give lot of problem. So we should bleed. We should press away. A button is there in the filter. If you can see here, there is a button. If you press this from here, some fluid will go and air will be removed. Cooling and heating provided by heat exchanger in return line. So because the return line will be more hotter than the pressure line, so in the return line we put the heat exchanger for the cooling purpose. During offload of the pump, heat to be extracted from the system. So during the return line or after the pressure is released, this has to be cooled. The heat exchanger should therefore be positioned to cool this flow before its entry into the reservoir. Filters are used to filter out particles of above 5 micron size. So filters are used to filter out particles of above 5 micron size. So this you should remember, that in hydraulic it is very clean is required, and up to 5 micron below is permitted. If any particle is above 5 micron, it has to be filtered out. So we need the filter. Its capacity should be 5 and above micron. If any particle which is more than this, it should be able to filter out. So we need such type of system. So now filters are capable under careful design test conditions of stopping all particles of contaminant above 5 microns in size and a high percentage of particles below this size. These characteristics has led to filter elements becoming known by an absolute rating. The two examples above being 5 micron absolute. So typically these are 5 to 15 microns, 15 to 25 microns, 25 to 50 microns and 50 to 100 microns and above 100 microns to be found in 100 ml of liquid. So in 100 ml of the liquid, if there is 5 to 15 micron, it is very good. We want in this range only, less than 5, or 15 to 25, 25 to 50 and 50 to 100 microns. But for the hydraulic, we need this range. For fuel, we need up to this range. Fuel, if somewhat is there, it is permissible. But in hydraulic system, it is not permissible. An adequate level of cleanliness can be achieved and maintained by the use of 5 micron absolute return line filter in combination with a 15 micron pressure line filter. So next, we have covered initially we have seen that pipeline, then hydraulic pump, then fluid conditioning, then filters, then reservoir. So what is the reservoir? Reservoir is a component where fluid is stored in an aircraft. So that is used for different application, and from there fluid is sucked by the pump. So the reservoir, in military aircraft, the reservoir must be fully aerobatic. This means that the fluid must be fully contained with no air-fluid interfaces, and a supply of fluid must be maintained in all aircraft attitude and G condition. Especially for military aircraft, your container or your reservoir should be in such a way that there should not be any leakage, there should not be air and fluid mixture anywhere. Supply of fluid must be maintained in all aircraft attitude and G conditions. Reservoir pressure must be sufficient to accelerate a full charge of fluid into each cylinder while it is open to the inlet port. The need to meet pump response times may double the pressure required for stabilized flow condition. The need to meet pump response times. The pump response time should be very fast. May double the pressure required for stabilized flow condition. The volume of the reservoir is controlled and includes all differential volume in the system, allowance for thermal expansion, and a generous emergency margin. To isolate leak within the system and to provide further protection of flight safety critical subsystem. The cutoff point must ensure sufficient volume for the remaining system under all conditions. Here I am showing a very simple, typical hydraulic system, and in this you can see that starting with the reservoir just now I told it stores the hydraulic fluid in this. From here the pressure goes, the fluid is sucked by the pump. Pump may be the reciprocating pump or the rotary pump. So from here it will go to the filters. Here also one filter is here in the return line. In the filter mostly we use the 5 micron filter. So any particle is more than 5 micron will be trapped inside this filter. And there is a mechanism we can remove by draining out from here. So all filtered item will be drained out. Before every flight we should drain out some liquid from here or fluid from here. Then it goes to a check valve. So this check valve makes sure that fluid will go only one direction. It will not revert back like this. This is not permitted. Only in this, only one direction it will go. Then we have the shut-off valve. The shut-off valve, the purpose of shut-off valve is to shut off or open or close the system. In case of emergency, if there is a fire in the aircraft, we will try to shut off so that this fluid is not reaching towards the fire. Otherwise, this hydraulic fluid itself is a petroleum product and it will cause more fire. To avoid that, there is a shut-off valve. Whenever we want that pressure should not go to the main actuators and other hydraulic jacks, we will shut off from here. Then we have the pressure reducing valve. These pressure reducing valves are used to reduce the pressure because different pump is producing more pressure, but we don't need that much pressure for everywhere. So as per the system need, we can reduce the pressure. Then it goes to the selector valve. This selector valve is used to select the line either from this side or from this side as per the requirement. As of now, this system is open. It will go here. It will compress this thing. Your actuator will move in this direction. As per, so here we have the one actuator, and here also we have the one actuator. So one is operated here, another is operated here. Then from here it goes to the return line. This is called the return line. So from here it goes to the again in a filter. This will again filter, and in so many we have the heat exchanger also. Heat to cool the oil. Okay, so this is a simple airplane hydraulic system which I have explained you here. But the real scenario, you have very sophisticated system. It is not like this. You have so many of valves, pressers, accumulators. Okay, so accumulators are here. So this accumulators here is charged by the nitrogen. High pressure nitrogen is charged. And here if you see, we have the hydraulic fluid. This hydraulic fluid is pressurized and your system is working in this fashion. So now we can see that here hydraulic non-pressurized reservoir. So there are two types of reservoir. One is a pressurized, another is a non-pressurized. Mostly in a small aircraft or in helicopter where the maneuvering is not very high, we need the hydraulic non-pressurized reservoir. In this, if you see that we have here filler neck. From here we remove this and we can fill our hydraulic fluid here. Okay, so from here it will go here. Finger strainer is also here, and a normal strainer here. A big particle will be trapped here. Normal fluid level here. Here we have a glass side gauge. From here some meter is here in this. We can find out how much is the fluid inside. Here we have the connection for vent line or pressurized line. So here we can do the venting, and if it is pressurized, we can give the pressure here. In between it is not full hollow. In between we have the fins here. These fins will make sure that sloshing of the fluid will not take place and equal amount of fluid is distributed among all. So after this it will go to the baffles here. These baffles are making sure that your fluid will not slosh here and there. Further we have the fin at the bottom also. So there are number of fins, number of baffles are there inside to make sure that the fluid is in a very balanced manner. The CG of this tank should not go one side. Here we have the glass side gauge. From here we can see how much level of the fluid is there. Here we have the connection for the return line. Here the return line is connected, which I have shown in the previous diagram. Connection for main system pump. So main system pumps are also connected in this here. We can see connection for the emergency system pump. So this is for the main and this is for the emergency. Main pump. And this is the emergency pump. So like this, it is a hydraulic reservoir is made like this. Now hydraulic pumps, this we can see, it is a driving and this is the driven. Fluid is entering from here, then it is going here and trapped inside this groove, and slowly it is pressurized, area is reducing, and same way it is going here and outlet a high pressure given as output. So most of the time we use the gear type of fluid pump, which I have shown you here, and the basic principle is I have just now explained. There is a driving and this is the driven. So this is connected with engine gearbox, and it is rotating and the fluid is trapped, and in this way the area of this trapped is reducing and the pressure is increasing by this way. This one is a hydraulic pump. Just I have explained you, there are 1, 2, 3, 4 like this 9, and this is the plate. This plate is rotated and they are compressed like this, and fluid is pressurized. So here is the inlet valve and here is the outlet port. From here it is pressurizing, entering here, pressurizing, and then it will go to the outlet. So this is a hydraulic pump with piston type of reciprocating pump. So it is also used, it gives very high pressure. But if you see this one, the gear type of pump, the pressure is not very high. So if you want a very high pressure, that time we have to use this piston type of pump. If you want a medium pressure, we have to use this type of pressure. But here the flow fluctuation is higher. In this, a very smooth flow is observed like this type of pump. Now I will discuss about accumulators and filters. So accumulators are devices which absorbs the energy when the energy in the system is more than the required. So here, if you can see, we have the nitrogen or air we are filling here, and another side is filled with the hydraulic fluid. So if the pressure of this thing is high, this will be compressed and here it will be stored. As and when the pressure of this hydraulic fluid is less, this will press here and the pressure will be maintained, and the remaining fluid will be used for emergency operation of the system. So like this, here is a bladder. Okay, here we have the retaining plug, gas servicing valve. From here we have to charge, N2 charging. N2 charging point is there. Here we have the rigid button or the disc to prevent extrusion. So here we have a disc. Here is the N2 and here is the hydraulic fluid. So like this, it is the construction of hydraulic accumulator is made. Another is the hydraulic filter. In this hydraulic filter, we have different. Here is the spring and here is the inlet. From here it goes. Here is filtration. Mostly a 5 micron filter is used. Any particle more than this will be trapped here, and a good fresh fluid will go here. Here we have the magnet. If any metal particles are found, then here is a magnet. This magnet will take the chips. These chips, during inspection, we will observe that what is the size of the chips, and we will also give for the detection that from where this material has come. If it is from the gearbox and the size is more than the required or the given amount of the size, then we have to observe that hydraulic pump and we should replace that pump. We have to remove and we have to replace. We have the thermal lockout here, and we also have the indicator button. If the fuel filter is more contaminated and it is clogged, this line will come out like this red, and the technician will come to know that filter is clogged. Like this we have to observe. Now we have the hydraulic valves. We have the check valve. I told you that the check valve will allow only one direction. It is also called the non-return valve, NRV. So it will go from here, it will press it and it will go from here. But if the pressure is low here, pressure is high, it will not go here because it will close this valve. So that is the purpose of this check valve. Then we have the sequence valve. This sequence valve will give a proper sequence and time delay as per the requirement of the system. Like if you want to open the landing gear, landing gears are packed inside the belly of the fuselage. So first door should open. So first door will open, and then this sequence valve will, after that only the sequence valve will give the power to the hydraulic jack or the landing gear. Then only this landing gear will come out and it will operate. So that is the purpose of the sequence valve. Priority valve. This is the valve which will give the priority as per the requirement. If the priority is to land, then only fluid will go to the landing gear. Other systems which are not that time required, it will not go there. Servo control valve. This valve will give the controlling capacity of the servo pistons or actuators. In this way it is working. Now we have the hydraulic fuses or the safety valves. In hydraulic systems also we have the, like electrical system we have the fuses. In hydraulic systems also we have the fuses. These fuses are called the pressure relief valve. So if the system needs some certain amount of pressure and pump is giving more pressure, this valve, the pressure relief valve, this will open and it will be released from here. And if it is the required only, it will go to the output. Otherwise it will not. Pressure regulator here. These pressure regulators are set for particular pressure. Here it is shown 200 psi. So if the pressure is 200 psi, it will give here. If the pressure is not that much, it will lift this thing and it will go to the reduced pressure 200 psi. Here is the relief valve 750 psi. If it is reached, the pressure will be relieved. 100-pound spring, 1 square inch piston, bleed office, system pressure 1500 psi. It is 1500 is coming, and if the pressure requirement is not up to the requirement, the pressure regulator will regulate how much is the need of the system. Next we have here the alternate system inlet and outlet. These are the shuttle valve. Warning and the status. So several instruments are fitted to ensure performance of the hydraulic system. So what are those warning systems which we should always have? So pressure transducer, monitor system pressure and transmit this signal to gauges in the cockpit. Pressure switches are incorporated to provide a warning of low pressure in the system on the central warning panel. Filter blockage indicators show the condition of the filter element to ground servicing personnel, and a fluid temperature warning may be given to air crew. Use of microprocessor based system management units. More in depth health monitoring of all major components is possible with data displayed to ground crew on a maintenance data panel. Emergency power sources. Just now I have explained about the accumulator. These accumulators, it is like this. So here is the charging valve. So what happens in the normal operation of the hydraulic system? The nitrogen, which is the high pressurized nitrogen, is charged. If the system here, the pressure is reduced, this will press here and the pressure will go here. And if the system is, your pump is failed, if your pump is failed, then for sometimes emergency operation can be handled by the accumulator. So gives emergency supply for canopy, wheel brakes, flight control system. So canopy, wheel brakes and the flight control, elevator, aileron and the rudder. To supply emergency power for longer period, an electric motor driven pump may be provided. So these accumulators are used for very less time. But if you want a more time, then we need some electrical motor driven pump may be provided. Battery size and weight are the main limitation in this case, and to minimize these factors, the flow available is usually kept as low as possible to operate only those devices considered indispensable. Weight may be kept to a minimum by the use of one-shot battery. Weight may be kept to minimum as a one-shot battery. Hydraulic pumps and our emergency electrical generator can be mounted immediately behind the turbine on the same shaft. Here, the hydraulic system of BAE, it is shown here. So, this you can see here that how these hydraulic systems of BAE is working, and this anti-skid brake, roll spoilers, stability fuel, DC pumps, electronics, here AC pumps is here, electrical systems are here. These are the 1, 2, 3 and 4 engines. They are operated by the engine 3, engine 4, engine 2, engine 1, AC pumps. Here hydraulic system is shown here. It is very big. It is not, this you can see here how big is the any hydraulic system. Yellow and the green system. So in whole aircraft, the system of hydraulic system can be divided into the two groups. One is the yellow and another is the green system. The systems are designated as yellow and the green and are normally pressurized by a self-regulating engine-driven pump on the inboard engine. Each system has an independent hydraulic reservoir pressurized by the regulated air bleed from their respective engine. The yellow system is on the left of the aircraft and the green system on the right side. Backup power for the yellow system is provided by AC electrical pump, and backup for power of the green system is provided by the power transfer unit driven by the yellow system. An electrically operated DC pump fed from a segregate hydraulic supply provides emergency lowering of the landing gear and operation of the brakes in the event of failure in both the yellow and the green system. So this we can see here that there are two types of hydraulic system in any of the aircraft. One is yellow, another is a green. This color marking is also given in each pipeline, each pump, and all the equipments are by the strap. A yellow strap and the green strap is mentioned. The yellow system is on the left side of the aircraft and the green system on the right. So left side is yellow and the right side of the system is a green one. But backup power for the yellow system is from the AC electrical pump. So yellow system is operated by the AC electrical pump if engine failed, and backup power for the green system is provided by the PTU or the power transfer unit, which is driven by the yellow system, which by the electrical operation. An electrically operated DC pump fed from a segregated hydraulic supply provides emergency lowering of the landing gear and operation of the brakes in the event of failure in both the yellow and the green systems. So the green systems, the yellow system powers the following services: flap motor, flap asymmetry brakes, roll spoilers, lift spoilers, rudder servo control, standby fuel pump, landing gear emergency lockdown, wheel brake including parking brake, air stairs through the AC pump, power transfer unit. So these are operated by the yellow system. So yellow system component in the hydraulic bay, actually here. So yellow system component in the hydraulic, I have shown here. The yellow system is in the left side, and here these are the accumulators. and all pipelines here, all pumps, all things are here. It is yellow system component in the hydraulic bay. It is called hydraulic bay. Here all the parts are fixed inside the aircraft. It is quite big room. There this all things are accumulated. References for this is Moir I and the Seabreeze A, aircraft systems, mechanical, electrical and avionics system. This is from the professional engineering publication. Again the same authors, Moir I and the Seabreeze A, design and development of aircraft systems and introduction, AIAA education series, AIAA 2004. If any questions, you are welcome to ask. I will feel very honored and to reply your questions. My email ID for this is ydwivedi@gmail.com. Okay, this is my email. Thank you for watching this video. Please do like my videos and give comment if any. We will meet you soon for the next lecture on the new topics. Till then, goodbye. See you. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.